All right, so this is continuing through our 4.5 and 4.6 lesson. We're going to talk through the irrational conjugates theorem. So the irrational conjugates theorem tells us that if a function has a 0 at a plus root b, then it must also have a 0 at a minus root b. Because if you think about our quadratic formula, we have that a plus or minus root b. So that breaks out into two different zeros. So if you're asked to write a polynomial of least degree with rational coefficients, a leading coefficient of 1 and zeros at 3 and 2 plus root 5. Right, so leading coefficient of 1, zeros at 3 and 2 plus root 5. Okay, so when I work through red problems, I'm going to do it completely and wholly, working straight through, not really pausing much, but you can hit the pause button if you want to, obviously. And then I'm going to do another problem in blue that I will actually take time. I will go through slower and give you moments to think about and see if you can continue through that problem. All right, so first problem. If I need to write a polynomial, leading coefficient of 1, zeros at 3, and 2 plus root 5, the first thing I'm going to do is make a list of those zeros. So zeros, and I'm given 2 of them, so I have 3, and I'm given 2 plus root 5. Then I need to think through that irrational conjugates theorem. So this is where that theorem comes in play. So the irrational conjugates theorem tells me that if I am told that I have a 0 at 2 plus root 5, I should always remember that there is also another ungiven 0. The irrational conjugates theorem tells me that there is also a 0 at 2 minus root 5. When you have zeros, zeros mean the x value that if you put it into the function, it would cause a 0 output of your function. It is also the x-intercept if I was to place this function onto a graph. We take those zeros, and in order to actually write out the polynomial function, we need to create factors with them. So if I have a 0 at 3, I must then have a factor of x minus 3. If I have a factor at 2 plus root 5, then I have a factor of x minus, I'm going to use brackets to put that in there, 2 plus root 5. If I have a 0 at 2 minus root 5, then I have a factor of x minus 2 minus root 5. So we have brackets within parentheses, so we want to simplify those out. So if I distribute that negative, I have x minus 2 minus root 5. And I have x minus 2 plus root 5. So it actually changes those signs. Still following the theorem though, so each of those are nearly identical except we are adding and subtracting that irrational piece of those terms. So the whole point of finding the factors is so that you could actually write out the factored form. So we're going to do the factored form of a function, and functions are represented as f of x. So we're going to start by f of x. So this is a function. And we allow the multiplication of all of the factors to represent factored form of a polynomial. So I have x minus 3 times x minus 2 minus root 5 times x minus 2 plus root 5. So when you have factored form and you want to get it to standard form, so we need a polynomial of least degree, so it needs to be written in standard form. The exponents need to be in order from greatest to least. Typically we'd work left to right, but because we have all those irrationals in there, it's actually easiest to distribute the two factors with irrationals first. It will eliminate and rationalize everything the quickest. So we are going to distribute the irrational factors. All right, so we're going to keep our x minus 3. So we're not using that term yet. And we're going to start distributing these factors. So x times x is x squared. X times negative 2 is negative 2x. I'm going to take, I need to take that x times root 5. So plus x root 5. Okay. Then I'm going to take that minus 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times root 5 is minus 2 root 5. Then I need to take this root 5, negative root 5, and distribute it times the x. So minus x root 5, negative root 5 times negative 2, so that's positive 2 root 5. And then I need to be very careful on this one. So I have negative root 5 times root 5. So I'm going to do this over here real quick. So let's see, negative root 5 times root 5. Oh, so that is the negative of root 5 squared. Oh, squares and square roots are inverse of each other. So that equals negative 5. Okay? So, minus 5. Alright, so this is what I was talking about earlier. If you distribute the irrational factors first, it will rationalize itself because of that irrational conjugates theorem, that you should have a positive and negative of each of those irrationals. So I have a positive x root 5 and a negative x root 5. Those zero each other out. I have a negative 2 root 5 and a positive 2 root 5. Those also zero each other out. So I'm going to simplify, and now I just need to combine like terms. Combine like terms. Alright, so I have not distributed that x minus 3 yet, so I'm still keeping that. And in here I have x squared minus 4x minus 1. Right, so now I'm down to 2 factors and I need to distribute those. So x times x squared, x cubed, x times negative 4x, negative 4x squared, x times negative 1, negative 1x, negative 3 times x squared, negative 3x squared, negative 3 times negative 4x plus 12x, negative 3 times negative 1, so plus 3. And I'm going to simplify that. Let's combine some like terms. Okay, so x cubed is what it is. I have some x squares here, so minus 7x squared. I I have some x's, so plus 11x, and my whole number plus 3. So this is simplified. All right, so let me double check. Am I done? Is this a polynomial? Yes. Rational coefficients? Yes. Leading coefficient of 1? Yes, there's only one x cubed in the front. 0's at 3, 2 plus root 5. I use my conjugates theorem to find the 2 minus root 5. There are 3 zeros, therefore I should have an x cubed as my first term, and it is, and done. Okay, we're going to do one more, and with this one I'm going to be pausing through so that you have time to try it on your own before I write it down to see if you understood what this process looks like. So hopefully you have